think he can say when.
Okay, you're on.
I think we better say when, everybody. Hey there. Welcome in to our Labor Day 2025 end of summer issue of the SBAU Astro Hour. It's number 236 of over 4 years of weekly vlog podcasts for September 1 through the 7th, 2025, all for the Santa Barbara Astronomical Unit. That's Santa Barbara, California's longtime astrophysics club. Just happens to meet at and is supported by the most family-oriented, beautiful, fun spot in town, out behind the mission. That would be the Santa Barbara Museum of Natural History. I'll be your initial host, Ronnie Herron, ready to turn it over to the guys I'll introduce you to in a moment. First of all, let's find out what we're going to talk about this week. Number 236, big Cepheid variable star in Andromeda that Edwin Hubble used to change astronomy about 100 years ago. Something about trigonometric stellar parallaxes in his orchestra. Going to find focus on the Great Square of Pegasus now that our moon is waxing again. The moon tightens shadow on its home planet, Saturn. We're watching.
That was a month ago.
What?
That was a month ago.
What was a month ago?
I'm reading from shadow on Saturn.
I'm reading from.
No, it's there again.
Yeah, we're going to visit it again. Great Square of Pegasus. That's all right. If it's well worth repeating, it's definitely in the news, guys. Alex Filipenko coming to town October 3rd. President reluctantly will be out of town, probably talking about a new class of exploding star he co-authored a paper about involving the Keck telescope. We pointed the Webb out at Comet 3I Atlas back on August 6th, and the Swan Nebula M17 will reach its highest point late tonight. Okay, for SBAU.org, that's where you check us out. Join us second Saturday night at the museum for our monthly star party. And this Friday evening, first Friday for UCSB grad student Ish Call, taking us out to galactic rain and atmospheres. And whoa, I'm totally lost on that one. Let's meet the gang. Jerry Wilson in charge, beloved President Jerry. Good morning.
Good morning, everybody. And good morning, Joyce. And good morning, Calvin. And good morning, Riley.
And you might want to apologize to the folks that lost us about three-fourths of the way through the program last Monday due to something that I think we're on top of, right?
Yes. Well, I don't know about on top of, but I know how it happened.
Okay.
I was sharing one thing and I forgot to unshare a previous thing and they locked horns deep inside my computer.
As long as you know, I need Tom Totten. He's sitting with me. We may do a two-man show here in a minute. Pat Forgy, your wife, is she okay today? Everybody fine?
Yes, she's good.
Okay, let's meet Chuck McPartland, our outreach coordinator for the club. Chuck is awesome, the best in the business, and we got him. His wife is even awesomer in many ways. He's got the new calendars in as merchandise manager. We'll all be buying the Astro calendar, what, $10 for the members, right, of the museum and the club.
Yeah.
15 for everybody else. And Pat is also.
And just to warn people, the meeting schedule has really changed this month. It'll be in the newsletter when it comes out on the link in a couple of days here. But we're gonna start opening up at 6 p.m. and from 6 to 6:30, the merch manager will be handling calendars and clothes and stuff like that. And then 6:30 to 7 is the planetarium show. 7 to 7:30 is when we'll do our club business, and then 7:30 will be the speaker.
7 to 7:30, it seems like socializing time, which we've never really had before, except after the meetings.
Well, that's our business part of the meeting.
Yeah.
Oh, we're going to be
it's also because we have to be out of there by 9.
Yeah.
So we're not starting the meeting the same time, 7:30. We're going to start.
We're moving everything up about a half hour,
including the meeting. 7. Okay. Yeah. The only thing I thought was different was the time for the planetarium show, but. Nevertheless, get there early this Friday night. Let's meet Tom Whittemore and his wife, Maureen, or she's off stage, Tom.
Right. Morning.
Monthly newsletter comes from him and a lot of incredible bread out of the oven. Westmont College science instructor, Maureen is his wife. And Bruce Murdoch joined us early this morning. He's on the screen. Longtime supporter, telescope enthusiast, and president of the Santa Barbara Theater Organ Society, married to Bonnie. And Tom Totten to my left, and Tim Crawford is on screen. Tim, married to Karen, thank you for joining us, resident expert. And I'm trying to talk him into doing a December in-house members-only speech. about his life story and how to build a lens or whatever. We start every week with silly stuff that has been forwarded to us by our beloved president. You sent out a bunch of them, a plethora, a lot of thought provokers, Jerry.
We're picking up background noise from somebody.
He's listening to us on the other computer, which is plugged in.
Oh,
You can turn it down, I think. Okay. Fantastic. All right, let's go to the silly stuff and minimize our pictures on the side and start the week here for Labor Day with a little levity, a little fun stuff. These things are awesome. I don't know how you keep coming up with them, Mr. President. Starting with,
I'm working.
somebody say warp speed, engage. Ooh, something's on the bottom of my screen.
You have to point too, just like Patrick Stewart does.
I see. Yeah, the difference between a biologist and a microbiologist is simply size.
And down here is the molecular biologist.
A what? Oh,
Microbiologist.
Molecular biologist.
molecular
I
biologist.
missed that.
They just deal with pathogens and
He runs away from pathogens, yeah.
okay, gotcha. Not bad. Same guy. All right. This one I don't recall getting, but there's a couple of dinosaurs, perhaps T-Rex in the grass years ago, like 65 million.
Uh-huh.
Hey, look up, George. That one looks like a giant asteroid coming our way.
Shadow.
And there's a shadow over him. Thank you, Tom.
Here in the shadow, yeah.
This one might need some explanation. The dog is sitting on what, a concrete berm in the ocean? My dog, after reading my philosophy book,
Yeah, he's staring off into space, wondering about the meaning of life.
contemplating his own navel. Got it. I understand
Yeah.
it. Those are little potted plants behind him. I'm not sure what
My
those
dog
are.
used to do that. She'd want to go outside and we'd let her out and she'd just sit on the back lawn staring up at the stars.
Bob Newhart used to talk about taking his cat to get fixed and he'd bring it home after it had been neutered and it would just sit on the television and stare at him. This is what a human hand looks like under the microscope. Tom, you get these, don't you? Yeah, Tom Totten is here with me. Orion's belt is a big waste of space, 29 inches. Terrible joke, only 3 stars. Okay.
Well, it's the way that waste is spelled.
Yeah,
Of course, that's
Right.
around your waist. That's the Orion's belt.
it's a pun.
Somebody else want to read this, Mr. President?
Stop asking candidates if they believe climate change and start asking if they understand it. It's science, not Santa Claus.
Yeah, I like this one.
Touche. You're right. Fascinating. All right. Those are obviously aliens that look like flies. Somebody want to explain this one and read it to us? Chuck, how about you?
Well, you've got some mosquito-ish aliens, and they're standing there, and one's holding a big fly swatter, and they're looking at a man standing next to them, and one of them says, "Don't use that thing. I'll get the spray."
Rain.
Yeah.
Okay, coming down. This is a good one. You guys all got these, right? How about Tim Crawford? You want to read this to us? What's going on? The sun's looking down at the earth, and it says,
Texas is so pretty at this time of the year. I'm going to take a closer look.
ooh.
And then it has the magnifying glass focusing the heat on Texas.
Yeah.
Melding it.
That's where they're all moving, is to Texas. That incredible climate. Well, let's talk cosmos, gentlemen. I'll just sort of let you guys take over and sit back and learn. Like I'm out at Broida Hall.
I'm going to mention real quick, we got our friend Astro Deli from India back.
Hey, Astro
He,
Deli. Well, he doesn't give his name.
No, you can send me your name if you'd like, Astro. I just call him Astro. He said since the last time he was here, he took his best shots of Saturn and the moon using Planet Cam and
Huh.
Planetary Cam. So that's
Chuck, could we send him our link to watch this Friday night? Ishkal could be a fellow countryman doing our speech.
Well, we'll see.
We'll see if he calls in, gives us his email address.
It'll be recorded on YouTube.
Yeah, that's.
I think he's pretty busy. He just said that he's really been busy, so that's why he missed a couple. He misses an off and on. So
It's the middle of the night in India right now.
yeah, absolutely. He's a pretty busy fellow.
Okay.
But anyway, well, nice to see you, Astro.
We missed all the excitement last week. Almost done, and we lost Jerry, but not this
Oh, I'm
week.
still here.
I know you are. I was talking about last week.
Yeah.
All right. What's this night sky showing here?
This is showing us the constellation of Cepheus, and the prominent in it is Delta, a star, which is not part of this red line house bit. Delta is right here. You can see the Greek letter. So this is the first Cepheid variable that was discovered. And it's in a good region up here. This is Polaris. It's a circumpolar star, which means that you can find it this close to Polaris almost any clear night of the year somewhere if your horizon is good. It never really sets.
Forgive me for interrupting, Mr. President. Tom Whittemore once gave a whole speech to our club about Cepheid variables, and I've forgotten most of what he said. Is it possible to describe one or define a Cepheid variable in just a few words?
We're about to launch on that.
Oh, okay. I'll come along for the ride.
Yeah. So anyway, but it's in a nice area. M52 is here, the Bubble Nebula. The blue snowball is over here. Cocoon Nebula, M39. And
Cepheid.
yeah. So anyway, let's see, how do I get to the next one? Oh, there it is. Okay, so a Cepheid variable is a variable star. And this is a typical one. And it has these asymmetric light curves. Apparent magnitude of this star, which is Delta Cepheus, goes between, say, 4.4 and 3.6 magnitude. So almost a whole magnitude. And a magnitude, as you recall, and if I recall it right, is 2.5 times in brightness.
Correct.
So this is, and it changes this over a period of days. So you can actually watch it change its period, or its light output. Now, back in the day,
is it just every few days, not every few years that it fluctuates?
No.
It's about a 2-day period, Ron. It was on that graph.
Well, I understand that, but is there a variation? Will it be years or months, or it's just regular, like a hard?
It's a 2-day variation.
Yeah, for that star.
For that one.
They're all around that.
Okay, got it.
And but different ones are in detail different. There is a brightness, luminosity, that is luminosity and brightness, I'm going to use the same way, and a period relationship that was discovered by Henrietta Swan Leavitt. She discovered a linear relationship, and this is her data plotted. So this is the observed different periods for different Cepheid variables, and they simplified it. There's errors in observation, of course, but there's one basic linear function relationship between them. So in principle, if you know the period of your Cepheid, you know exactly how bright it's flicking between. And so you can figure out how bright it appears, and you can do an inverse square law for the decrease in brightness with distance, and it gives you how far away that star is. That's a very accurate measure, and it's used for things up to galaxy distances.
That's how they do that.
That's how Hubble did that.
Hubble did that, and he did it. He did it with this photograph. This is a copy of a negative of his, and he's got up here, see these two lines right there, and there's just this faint little dot right between them.
Well, that's one of the novas he was looking at, but the actual one is up above in red.
Yes.
Yeah.
So he's looking around at these things, and this one is, as Chuck points out, variable. So this is the first variable, Cepheid variable he found, and from that relationship, he was able to determine that this thing was 2.5 million light years away, and it was definitely outside of our galaxy.
Well, he got a smaller number.
Right. Right.
Well, what's the dark blotch at the bottom?
That's the core of the galaxy.
Yeah, that's the core. And this is a negative. So this is a bright core.
Okay,
And
got it.
these are dark lanes of dust.
Got it.
This
Okay.
is a plate from October 6, 1923. They're on glass plates.
He writes
So,
VAR. Okay.
okay. Oh yeah. In on April 26, 1920, astronomers Harlow Shapley of Mount Wilson Observatory and Heber Curtis of Lick Observatory held what was called at the time the Great Debate at the Smithsonian Institute in Washington, D.C. The topic was the nature of spiral nebula and the scale of the universe, because they saw all these spiral nebula, and the debate was, are they outside, are they other galaxies, or are they nebula, clouds of material in our galaxy? Curtis argued that they were galaxies like the Milky Way out there. Shapley claimed, no, you're nuts. The Milky Way is the entire universe. So that was in 20. And then 3 years later, Edwin Hubble, using the Hooker telescope, measured this variable, 1n var, and determined from that, you're right, it's a shorter, he got a shorter distance, but it was still on the order of not possible to be in our galaxy.
So up until that point, they knew about variables. He certainly wrote VAR, but
Yeah.
they were only seeing them and analyzing them in our galaxy.
That's
They were seeing them wherever they were.
They wouldn't know if they were seeing one in another galaxy. I guess the only one you could see was
The way they figured this out is Henrietta Swan Leavitt was measuring stars in the small Magellanic Cloud, which is a small galaxy orbiting ours.
Right.
And so she knew they were all at roughly the same distance, although I'm not sure she knew what the distance was at that point. And so that's where she derived this period luminosity relationship. And then from ones that were close by in our galaxy that they could do parallax with, she could figure out the calibration for the luminosity curve. And then Hubble used that when he finally got a telescope powerful enough to resolve these variables in the Andromeda galaxy.
So not only did he see a star in another galaxy, he could see it dimming and brightening again every, 2 days?
Yes, rough. Well, I don't know what the period was on this one. It varies from Cepheid to Cepheid.
Okay. Do we know what percentage of the stars are Cepheid variables?
Tom might have a handle on that.
No, I don't. Yeah, I don't have an idea.
Yeah, see, this chart from Harriet was it shows different Cepheid variables, and this is the logarithm of their period. So this is different periods.
Yeah.
Wow.
And they're going to be, they're luminous stars, so there's going to be a fair number that you can see in our galaxy.
Yeah.
I'm amazed he could see a star in another galaxy. We could barely see the galaxy.
Well, he couldn't see it. He photographed it.
Yeah.
I know that, but geez, to us, it's a tiny little blur that we can barely see.
It's 6 times, Ron, it's 6 times the size of the full moon.
Is it really?
Yeah.
It's about 3 degrees across.
Yeah. Yeah.
Fascinating.
Okay.
Got it.
This is the hand-drawn curve from
really washed out.
Yeah, I can't tell anything from that.
Okay, here we go.
Should we say goodbye now?
Now let's go, ye of little faith.
Just for my edification, there are other types of variables, right? Variable stars,
Yes.
we talked about them, but they're not Cepheid.
There are lots of different types.
Really? What's the difference? Just the spacing, the regularity, the brightness,
the causes, all kinds of things.
Yeah.
Okay.
Color.
Okay.
Is this better?
Oh, yeah.
Oh my God,
Okay.
yeah.
So this is a hand-drawn light curve of that variable, number 1, in Messier 31 by Edwin Hubble. And you can see the characteristic asymmetric shape of it. up in there. And this was the period he got down here. And so from this and using that rule, he was able to find that the distance to the Andromeda galaxy was in the millions of light years. So it was definitely, so that settled the debate.
Does this show that it was brightening fast because of the right slope versus the slow?
This is
Yes.
a fast rise, faster than this decline.
Got it. And that's what it would look like on a long scale. It would look like a heartbeat. That's kind of strange, but they're regular, right?
They
Cepheid?
all, yeah, they all have this characteristic shape.
Okay.
There's a lot of variable stars, as Chuck points out, but if the light curve has this kind of shape, then it's a Cepheid variable.
Tom said 20 days. That's on the bottom of this. 30 days?
See, these are days right here.
Yeah.
There's 0, there's 20, there's 30, 32 days. He did this over a month.
God, you'd think it would have disappeared on the bottom part of that, wouldn't you? Did he
Well,
see
that was
anything?
magnitude, this is 18.8. Now remember, he's using his backyard 100-inch telescope.
Yeah.
Backyard.
Mount Wilson.
He was on Mount Wilson, wasn't he? Okay, got it.
Yeah.
Fascinating.
Yeah, and the brightness changes about a factor of 2.
Wow.
Yeah. From 18 to 19.2.
So have we found Cepheids in some of those little galaxies that orbit us, like Magellanic?
Yeah.
Ron, that's where they discovered this period luminosity relationship.
But this one here where he wrote VAR is in Andromeda,
Yes.
Yes.
not in the local.
But Henrietta Leavitt was the one that found them in the Magellanic Clouds.
If there were no Henrietta Leavitt, there would be no Edwin Hubble.
Yeah.
That's right.
We're going to have to name a telescope after her, like Vera Rubin got hers.
Okay. See this?
Yep.
Yeah.
Okay, good.
It's a little blown out. It's going to be hard to see the indicated star.
Oh, okay. I'll go back to the other way.
Soup. This bright soup is what it is. I don't know how in the world.
It didn't look too bad.
You want to join us on screen? No, yeah, okay. I have my nanny here with me.
Okay. This is a very nice photograph of Andromeda taken by Tony Hallis, who used a 14-inch classic Cassegrain. He doesn't like to use Ritchie-Chrétien telescopes because the field curvature causes stars to be blurry at the center or the edge. You get them nice somewhere else or at an average between them. So he uses a classic Cassegrain for field flatness. So in there, this is an insert that shows up in, I believe it's up in this region.
Yeah.
It shows the star that Edwin Hubble made or observed, the Cepheid variable. And the reason this is there is because an amateur decided he wanted to measure this star too. And that's what the rest of these pictures are about. There's this amateur whose name is Rod Pommier.
And he just happened to have a telescope that could see that sucker?
The camera that could see it.
Yes,
Camera.
the thing is
Camera.
that, see, back when Edwin Hubble did it, he did it on photographic plates.
Right.
Photographic plates have a feature, a bad feature called reciprocity failure. If you take a picture that's twice as long in exposure time, you may only gain 10% in negative density. The sensitivity rolls off for longer exposures, and he was taking long exposures to get that star. What we do with our solid state cameras, CCDs and CMOS cameras, they do not have reciprocity failure. You double the time, exposure time, and you double the negative density. So we can take pictures in a few minutes that took him, even with the 100-inch, it took him an hour to measure to get that photograph. So
Wow.
the technology has made major advances due to those kind of solid state cameras.
And Jerry, you've seen the 100-inch, right?
Yeah.
I have.
Did he sit in an observer's cage like he did at Palomar?
I don't believe so. I think
No,
like
no, he looked through and he's,
Yeah.
at the business end, Chuck.
Okay.
Yeah,
Because
yeah.
at Palomar, when people were taking
Right,
long exposures, they actually sat in a little cage up where the secondary mirror would go at prime focus.
Right,
They were sitting in the telescope and sitting for hours taking these pictures.
right. Freezing.
I know
Yeah.
that when Palomar was new, there was a sign inside that cage where people sat and it said, if you feel yourself falling, try to fall away from the mirror.
Yeah, if you
Oh,
look real
God.
carefully. So Ron, if you look real carefully towards the very bottom, not that other bright galaxy, but towards the bottom, way down there, there is a real distant galaxy. Look at that.
Oh, that little blur is not a star, obviously.
Nope.
Oh no, no, it's probably
Well,
spiral.
now Andromeda would be the limit on being able to tell distance of galaxies. Beyond that, there's no way we're going to see any galaxy stars. So what do they use then? Parallax?
Run.
No, no.
With Hubble, we can see individual stars and galaxies, Cepheids, quite a bit farther away.
Right.
Yeah.
Really?
Yeah.
Especially if we use our modern cameras.
Yeah.
Well, also you're outside of our atmosphere, so you don't get the wiggle.
Yeah.
Yeah.
My understanding was you can't even see half the stars in our galaxy. They're just, I guess they're red dwarfs or they're too far away, or and yet we're looking at
But
individual
the
stars.
Cepheids are bright.
Okay, so they're the ones that we can see in distant galaxies. The
Now,
rest of it's just a white blur, right?
can I
No,
make
you can see O and B type stars too.
can I make a comment here?
Go ahead, give it a
way
try.
the way that I understand it is that the Cepheid variables, they act like a standard candle. In other
Right.
words, if you know what a headlight on a car looks like, if you see a headlight up in the mountains, it looks a certain dimness, and then if you see a headlight coming down your street, it's much brighter. But you know it's still a headlight. So that's a standard candle, and the Cepheid variables they kind of act in the same way. So we're kind of measuring distances all over the place using this technique. Before they probably used parallax.
If they could, yes. Yeah, good analogy.
Well, parallax will only work so far, and then at some point we use infrared, right? Way out there.
That's not going to make a difference between distance candles.
Oh, it isn't.
No, unless you can infrared, you can sometimes see through dust clouds.
Ron, what you mean is redshift.
Yeah,
Yeah.
redshift is what I meant. I'm
Oh,
sorry.
yeah. Okay. Anyway, this is Ron's amateur picture of that star, the Cepheid variable. And
Looks like a triangle.
there's a triangle of stars. So there's a little asterism here of triangles. See, but this right here is the star.
Right.
That's the one. That's
Yeah, the arrow helps you find it.
Yeah.
that's
Yeah,
the
so
one.
he had an easy job of it. He just followed the triangle.
Yeah.
Like Pluto.
Yeah.
Yes.
Now
We're
this
talking
is his light curve for that star, going between 18.6 magnitude and 19.8. So apparently it hasn't changed its period. So once a Cepheid, always a Cepheid up to a point, I guess. But it has roughly that same shape, a slow decline and a rapid uptick.
Kind of looks like a saw blade.
Yeah, it is. It's on a bias.
We're still talking about Hubble.
No, this is
No.
the amateur repeating Hubble's
Oh,
measurement.
Yeah.
But okay.
Yeah, there was a real nice article about this, several issues ago. I think it was in Sky and Telescope, about amateurs actually measuring this.
Yeah. Okay. I didn't. Well, this is from Astronomy Magazine, I
Yeah,
think.
that could have been the thing I'm referring to.
Yeah. So anyway, Hubble Space Telescope's chief goal is to precisely determine the distance to 10 Milky Way Cepheids by measuring their trigonometric stellar parallaxes. So they're calibrating the lady's distance calculation for Cepheid variables. And the equation for the period luminosity relationship using the HST calibration is this, where M is the magnitude, M is absolute magnitude, and P this is absolute magnitude. This is the period. Someone want to say something?
Is the period in days?
In days? That's what I was going to ask.
Yeah.
Probably days.
I don't know. I would assume.
Maybe Julian days or something make it easy.
They use days down here. Yeah, astronomers use Julian days for this because you can do the math on the date much easier. So that's sort of the standard. So how close could you come to the current accepted value? A period of 31.9.
Wow.
31.9 days, and absolute magnitude yields a magnitude of minus 5.27. So it's a very bright star. Remember, -5, that's like Venus in the sky for our eyes.
Right. At 10 parsecs, though, Jerry.
Yeah, so really bright.
Yeah.
Yeah.
Extremely bright.
Then the distance modulus is given as whatever, and that's 2.531 million light years.
Yeah, that's backyard precision.
Yeah.
Yeah. So this was not the number that Hubble came up with, but it was close enough that he settled the debate.
Seems to be when you use the word trigonometric, you're talking sines and cosines and angles.
Right, that was for the parallax, but this
Yeah.
is the period luminosity.
Yeah.
Okay,
What
what does log mean? That log.
Logarithm.
Oh,
Tim,
logarithm.
Tim,
Log
you see
is-
the logarithm there?
Yes,
Yeah,
I do.
There will
Log-
be questions about that next week.
Okay.
So the log of a number p is the number that 10 has to be raised to get the p.
Right.
That's where I lost it.
Okay.
Yeah.
If this said ln, then it would be Neperian log, which is to the base e, not 10. Okay, I'm going to have to switch to the other one. This
But
one.
in astronomy, we more often than not use log base 10.
Yeah.
Not Naperian base.
Well, we're at the halfway point, gentlemen. Amazing what these classes are like. Feel like I'm in Broida Hall out at UCSB.
I'll be asking you, Tom, about Naperian base.
That's that we don't use that much in astrophysics. Use it in decays and things like that for elements, stuff like that. Okay.
Okay.
All right.
Now
Quintet.
we're looking at stuff we didn't get to last week. Last week.
The Zoom gods.
So this is the Great Square of Pegasus. I titled it Square's a Square, North or South. When I took my first visit to Australia for an eclipse, I was very confused by the southern sky because the sky has always been like a friend. I know my way around it. But being upside down, it really threw me for a loop. But the Great Square is a square no matter which hemisphere you're in. And so I was able to orient from that. And it was low on the horizon, but we were in Queensland, which is close to the equator. So this is Stephan's Quintet, one of my favorite things. And up in this area is the Deerlick Association.
Mm-hmm.
What I found odd was, this is from Astronomy Magazine, I guess, and they said, yeah, we've got this waxing gibbous moon, but you can go try to find these really dim galaxy groups.
Good luck. Yeah. I mean, I've seen this quintet, Chuck, in my 18-inch.
Yeah.
And 7331 upstairs there is an easy catch, but these other guys are pretty tough.
Yeah.
They're tough.
Yes, I saw this in at a CalStar meeting, our camp out on I forgot his name. But anyway, he had a 20-inch f5. And there was no mistaking, you could see the 5
individuals. Yeah.
It was the dramatic. I went back to my 12.5-inch and maybe I saw it.
You put it back in your tent.
Yeah.
Is that Steve Kennedy?
No, it's the Wallace.
His buddy, Tim, his buddy.
Okay.
What was his name? I used to see him at star parties.
Yeah, something Wallace. But anyway, he wrote a book of his visual impression of virtually every planetary nebula you could hope to find with your scope.
Oh, that's somebody else.
Oh, I met that guy.
Kenton Wallace or something like that. Ken Wallace. Anyway, yeah, and he mailed he went down to Australia for a summer, and he mailed his telescope to himself and then to a club down there, and they held it for him, and then they put it together, and he did it in the South too.
You know, I was
Kevin
on the guy's
Wallace.
scope, that 20-inch. We were talking about the blinking planetary, and I asked
Yeah,
are there other stars like that? And somebody led me over to this guy. He
yeah,
said, "You want to ask him?"
Yeah.
yeah.
Does anybody know where the group of galaxies got the name Deer Lick?
I have no idea.
Forget.
But this is NGC 7331,
Yeah, very famous.
a target of my camera many times. And these other galaxies that may or may not be gravitationally, probably not because of their relative size change. But this group is called the Deer Lick Association.
I think it came from, the idea of deer around a salt lick.
I think that's right.
Those
Could
gotta
be.
be like,
That sounds right.
I was going to joke about it, but it's amazing.
those animals need salt, don't they? Cows need salt. We need salt to a degree,
Yeah.
I guess.
Yeah.
Deer
And
Lick,
Ron, a fellow named Harlan Arp, A-R-P.
Yeah,
right?
He used to look at galaxies like this to see if they had common redshifts, to see if
Huh.
they were moving the same rate through the sky
Huh.
as one another.
Interesting.
that's one indication.
Halton
of
Arp.
the group. Halton C. Arp, yeah.
Yeah, Halton Arp.
But this is another local group, just like us,
Yes.
Triangulum. And
It's a little more challenging. Since we had a computer failure last week, I took this segment and added to this week, and I took out the part where it said, now that the moon is dark. And so it may look funny, but it's left over from last week.
What's the group on the lower left?
That's
That's
their
Stefan's
Stefan's
quintet.
quintet.
That's the quintet.
Yeah.
Those
Now
are
that
five
quintet,
galaxies.
you would need at least an 18-inch to see that.
Again,
Usually, I think yes.
yeah, without a camera, Tim.
Yeah.
Oh, wow. Wow.
I
I've
got
seen it.
I got a hint of it at a 12.5-inch f6.
Well,
That's pretty good.
Woody was showing it at Refugio.
Oh,
He was
really?
showing Stefan's quintet with his little 6-inch.
Yeah.
Okay.
But it has a sensitive f2, focal ratio and a camera.
Wow.
Too much.
We should get the Sea Star people to give it a shot.
Yeah.
Yeah. Yeah.
I think
I was going to say, Ron, what makes it 5 down there on the lower left is you can break those two apart. You see those two that are hanging on one another? Right there.
Yeah. The middle, yeah.
Yeah, right there. That breaks into 2. So there's 5 down there.
Okay, I thought just above that, that's just a bright star just above them.
No, that's
no,
another
that's a galaxy way back.
Yeah.
There's a lot of galaxies in here. There.
Yeah. This is quite a shot, Jerry. Who shot this?
This, not me.
Huh?
Just a minute, I'll look it up here.
Oh,
That's Mike Germani.
Oh, okay. Yeah, I know that name.
Yeah, you got to it before. He did it from Vancouver, British Columbia,
Okay.
using an Astrotech AT92 telescope, ZWO ASI 53MC Pro camera.
Yeah.
So that implies
I
like
was-
a 92 millimeter telescope.
Yeah. I was surprised to learn that ZWO makes the Sea Star. I didn't know that. Chuck told me about it.
Huh.
Chuck Watson.
Yeah.
I helped him a lot yesterday.
One of the things I heard on our Telescope Tuesday, not Telescope Tuesday, on our telescope workshop on Tuesdays, is
Mhm.
that people are complaining about ZWO software won't address any other camera other than ZWO,
Oh,
while other software for photography will work with any camera. I
yeah.
don't know if that's true or not, but
Yeah, many years ago when we were having, the professional come out and tweak the 24-inch,
yeah.
and make it find things better. It was a little ZWO camera that they hung on the end of that scope, and I was really impressed with that thing could see. It's amazing.
They're excellent. They're excellent cameras.
Yeah.
I have one of them.
Cooled and everything else.
We're getting feedback from Ronnie's microphone again.
I don't think so. I don't hear it.
Chuck, can you forward to me Woody's contact information? He was asking about places that we go to do our astronomy.
Sure.
Yeah, is Tom next to you watching on another computer?
Yeah, he is.
That's
That
where
could
we're
be
getting
it.
the feedback.
That could be it.
It's muted. It's muted. It's muted. He's turned the sound on.
No, it's not muted. We'll not pick up his voice, but muting it, what he needs to do is turn the volume down for his speaker on his computer.
We're muted. YouTube is muted. We can't hear the video.
Well,
No,
when I
not
speak,
Can't hear video anyway.
when I speak, I hear it echo back from Ronnie's camera.
I'm kind of hearing it too. Do you know what that is?
No,
You're not even on us. You're on something else.
Tell Tom to turn the volume down on the speaker on his computer.
it's off. That's on.
Go to the lower left and move the cursor all the way to the left, and you'll be able to call up the icon that controls the sounds.
Yeah.
I'm not really hearing it, but I am kind of hearing something there. Yeah, okay.
Let's see if we can.
Here it goes. It's down. Is it gone?
No,
No. Okay, so much for my idea.
we'll live with it.
Yeah.
Guess we'll have to turn it off. I got my old and I'm on the new.
Okay.
All right. Here's Saturn.
Anyway, Saturn is showing very nice. It's up all night, essentially, at whatever time I said. You can catch Titan about to cover the planet and its shadow already on the planet.
But that's in August.
Oh yeah, the shadow transit's beginning.
Can I make a comment about Saturn?
Oh yeah, that's what you meant about a month ago.
Yeah.
Yeah.
Well, it appears to me you can tell by the ring that goes across the planet that we see whether we're looking sort of up or down. Is that a fair statement? Down on the rings in Saturn or up on the? Is it a half and half thing? Half the time
We're
we see
looking up on the rings because you see the bottom side of the near ring.
exactly. That's my point.
Yeah.
Yeah.
But
And-
actually, the caption on the picture says September 3rd, which is today. The one
No.
up at the top is either a.
No, it was August 3rd.
Was it?
Yeah.
Today is September 1st.
Yeah.
Yeah, but it
You
was
said it
August
was
3rd that this happened.
Well, it happened then too.
Yeah, I don't think it's happening again because I was kind of keeping track of that, seeing if I was going to try to image it.
Well, you might be right. So we'll just move on there, tail between our legs.
Well, I mean, it's still a cool thing that happens
Yeah, it
only
is.
when we're near ring plane crossing.
I hope you guys saw it.
I just want to let you know we muted Duran's computer, from Zoom, and the sound didn't go away. The YouTube is not playing on the other computer, so somebody else is causing the interference there.
Okay.
You can try muting yourself and see if it makes a difference in getting that scratchy sound.
Okay, I'll mute me.
Okay, nothing.
It went away.
No,
Did
there's
it go away?
something there. Yeah, I still hear it.
Yeah, and I muted myself and it's still there.
Is this from the Filipinko article?
Maybe Bruce, can you mute Bruce?
The big screen that I have on doesn't have audio.
But you're just mute your Zoom for a second. Your Zoom microphone.
I don't think he's going to want to do that.
Well, to answer you, Ronnie, yes, this is from the Filipenko article.
No, I don't even have audio joined on my big computer.
Well, we are listening to you.
I know, because I'm talking to you on my cell phone.
So mute your cell phone, Zoom.
Audio. I don't know what's going on here.
Doesn't
Well,
bother
let
me.
me, hang on, I'll mute I get my pointer here. Someplace down on the bottom amongst all this stuff. Is it that one?
Hey, Tim, if we were at sea, Tim,
Uh-huh.
if we were at sea, this would be called mutiny.
Yeah.
Warp speed. Warp speed
Yes,
indeed.
the topic we're going to go next is where Alex Filipenko, our speaker for October 3rd, professor of astronomy at UC Berkeley, co-authored this paper.
Do we have it now?
No.
It went away now.
Yeah.
Ah,
Okay.
Not to blame. I'm trying to get Totten to come on. He is Mr. Technology. He's our webmaster. Why don't you lean in and wave at everybody? All right. What is this a picture of? Because Tom sent it to us.
This is an artist rendition of what was deduced from watching the light curves of this new type of supernova. So this is the star that's undergoing explosion.
You can see the inner layers of the supernova. The inner layers.
We had supernovas, hydronovas, hypernovas,
Yeah,
kilonovas. Do they have a name for this nova?
I don't know. I didn't
It's a
find it.
it's a supernova, but a different type.
Yeah.
And they gave it they give the designation there. It's how many emission lines they see.
Okay, and is there a name for the star?
Some catalog name, sure.
And this was in an astronomy magazine article. And
No,
Alex
this was an
Philippinko.
article that someone sent to me as an
Tom?
email associated with Alex Philippinko.
Yeah. Okay, so they were looking through the Keck 1 telescope, and where is that? Arizona?
No, that's Hawaii.
Yeah, Hawaii.
That's Hawaii. What am I
And
thinking?
this supernova is SN 2021 YFJ. So that's
So it happened late in the year.
yeah.
All the Keck telescope was at Westmont.
Yeah,
Yeah.
that's
That's
same
also a Keck
funding
telescope.
agency, but a different scope.
Yeah.
Well, how far
Tim,
across?
Tim, if this appears on your nose, you can remove it with a salve.
Yeah.
How far
Okay.
across that bubble is it, you suppose?
So this thing has 2 layers that go out from it. The first picture was the first bubble. This one is a second bubble that's coming out much faster. See, the color is slightly purple. And this
Yeah.
yeah. So anyway, just find this. There's the episodes ejecting. The ejecting shells rich in silicon was the first shell we saw, and that's gray. And the second shell here is sulfur, and sulfur is yellow, and argon is this purple color. And the collision of these 2 shells is what produced the real big supernova flash, I think. So they show a video where this one caught up with this one, and then the whole screen blanks out. And in that flash, they got this spectrum. But I'm going to try and go back and
Fascinating.
Bruce, I think that feedback is coming from your phone or
Yeah, definitely.
yeah, so it's I don't know if you can move it further away or something.
I don't know how that happens because my big computer does not have audio or video.
Well, it's happening, and I don't know exactly.
It's inside the cell phone.
We're buying you a laptop, Bruce, but you got to wait till Christmas.
All right.
Yeah.
So the inner shell collided, it caught up with the outer shell, and whatever do we
yeah.
get? 2 or 3 explosions,
No, one major explosion.
which was when the shells met. But what were the shells representing?
They were okay. So, Ron, there were 2 events in there. They're calling them pair instability events. So it must have been a really massive star. And they sent shock waves out that basically pushed off parts of the atmosphere, and it did it in 2 pulses. And so the second pulse was more energetic, and it's catching up to the first pulse.
And that's never been seen before. This is something totally new.
Yes.
Was it in our galaxy or another galaxy?
I don't know that.
Yeah, I don't either.
Well, it looks pretty detailed. Could we get that kind of detail in another galaxy?
Artist.
Or an artist thing, okay. And they don't have a name for it except for a phone number for that star. Just
Phone number.
one of Neil deGrasse Tyson's phone numbers. They're all over the sky. You know.
I bet we'll be asking Philippinko about this.
I bet he's going to be overwhelmed that night.
Yeah.
Well, he's going to be talking about how he got into astronomy and things like that. So I
Can
don't
you
know
see-
if he
can you
wants
see
to go into
this?
technical. Yes.
Okay.
I'd be able to talk about it at the end of the show.
Now this is an artist rendition of what they figure happened.
Okay. An animated one, no less.
Break our computers.
Whoa.
It's second shell, inner shells.
Boom.
Whoa.
Whoa.
And
Well,
that's the residual.
So somehow they were looking at the spectra and they could see the inner layers of the supernova.
Yeah, because there were different elements, heavier elements.
Oh, that's interesting.
Isn't there still a shell around it? Did it go away?
Well, it got kind of
Those
fragmented. Looks
colorful
like.
things you saw at the end.
So they had to have seen that happen. If the artist turned it into an animated explosion, they must have.
These are images of that star after the flash.
Wow.
Whoa.
Man, oh man, you don't survive that, do you? If you're on a planet.
This listed again as an artist illustration,
It
so I
does,
don't think
doesn't
that's
it?
imaging.
Yeah.
I think it was all done spectroscopically.
Well, this is the purpose of the data take was spectroscopic. Yes, definitely. And this is the spectrum, and you can see magnesium, sulfur, silicon, silicon-4, carbon-3, argon-3, and helium. So,
Why do you suppose there's 3 sulfurs up there?
oh, they're different states, different ionized states of it.
Ionization.
Two of each. Okay, got it. Right.
4 and 3.
4 and 3. Carbon.
And when you start forming sulfur, the next step is iron after that. So this thing's getting,
Getting up
close
there.
to another boom.
Well, isn't that what made the explosion? Hitting iron? Isn't that when they blow?
No, they were saying pair instability. So that's a different thing that happens when it's a very, very massive star.
Pair instability. You're talking about a binary?
No, it's where there's so much going on in the star that you end up with matter antimatter pairs, and then they annihilate, and you get a big boom.
Whoa.
And then all the elements on the periodic table above iron get made in that explosion, don't they?
No, those
No, I thought
no,
that was-
they in some do in small amounts, but it's mainly kilonovas that do that.
Okay, and this is not a kilonova. A kilonova is a smaller, isn't it?
Yeah, kilonova is a collision between two neutron stars.
That's when we get the big heavy uranium and
Yeah,
uh,
most
You're
of
right.
it.
This is an artist illustration of the supernova's aftermath. Even after the star was stripped down to its core, it continued to experience violent mass loss episodes, ejecting shells of material rich in silicon, gray, sulfur, yellow, and argon, purple. The catastrophic collision of these massive shells is depicted in this illustration generated a brilliant supernova explosion visible across 2.2 billion light years of space. So
Okay.
I would say this was not in our galaxy.
Yeah.
not in
2
our
billion,
galaxy.
2 billion light years.
So it took the Keck scope to do it.
No, this is an artist's rendition of that spectra.
I know,
but it happened to be that the Keck scope was in use, and this object was visible, so they were able to slew to it quickly and get this data.
Yeah.
in another galaxy.
Yeah, 2.2 billion light years away.
They can zero in on another galaxy with something the size of Mount Wilson or Keck or any of those others. Certainly, they're moving.
Remember, it doesn't matter the size; it's the amount of light you get.
Right.
Okay, and it just cruises around, hitting star after star, and this one happened to blow.
No,
Oh,
they knew the thing had blown, and they let him know at Keck, and he slewed the telescope to this target.
They were looking at something
okay.
else.
So because of the vast distances involved, we're just looking at suspended animation. It's moving, but we can barely see it, I guess.
They think of it this way: they let the regular students out of school first, and then they let the track team out.
Yeah.
Well, of course, that makes sense.
It's just all by spectra.
Spectra.
Is the order of burning elements in stars, is it always the same, or is it dictated
Yeah,
by the
it
size?
pretty much is the same.
Okay.
Well,
I mean, our sun won't do that. Our sun will never produce iron, for example.
Okay.
It
Really?
stops at like carbon and oxygen.
But it is going to become a red giant.
Yes.
Whoa. Can't wait for those days. Can you, Tom?
They'll be there.
That's going to be fun. I'm going to get a smoke detector just in case. Wow. Love the stuff we learn on this show. I would just wish I could retain it. And I
So
assume
this is a James Webb Space Telescope with the near IR camera looking at the interstellar comet coming into our system right now. It's not a spacecraft.
Atlas.
It,
Is it MI Atlas?
yes, 3I Atlas.
3I Atlas. Okay.
3I. It's the third eye.
Yeah.
Interstellar. These spectra were taken with this near IR spectrograph, and they show carbon dioxide, water ice, carbon monoxide, and carbonyl sulfide in its coma.
There was a fellow at Kachuma that I overheard talking to somebody, one of the campers, and he said, yeah, he saw YouTube proving that this was an alien spaceship because it was giving off carbon dioxide.
So that's what the I means, interstellar?
Interstellar, yeah.
It's a visitor like Oumuamua, but Oumuamua didn't have a tail, right?
Oumuamua had a tail, but it was very tenuous.
Yeah.
And
what these spectra imply is that the comet may be on the order of 7 billion years old, 3 billion years older than the solar system.
Oh. And it may have a crusty outer shell that is protecting water ice from being exposed to the heat so far, but it may break out as it comes closer.
And due to the inclined shape and the speed, they're backtracking the orbit, and they claim it came from the Milky Way's thick disk of stars, as opposed to the thin disk within which the sun is located.
We're in the thin disk, not the thick disk.
The thin disk is farther out. The thick disk is closer into the bulge.
Are we talking?
No, it's the other way. The thick disk is the thin disk is oriented along the plane,
right?
And the thick disk is a wider version of that, higher above the plane and lower below the plane.
Okay.
We're talking about the ecliptic?
No. The ecliptic is just our solar system. We're talking about the equatorial plane of our galaxy.
Okay, got it.
But wouldn't the thickest part of the galaxy be the center of the galaxy?
Yeah, that's the bulge, but there's also a thicker region of the disk.
But it only has to have originated from a single star.
Yeah.
System, and there's lots of stars above and below our disk, so it could be the way Chuck says.
Well, do you suppose, Mr. President, we're going to learn like they're finding thousands, millions of little dinky black holes going everywhere, and now they're finding rogue planets, that we have these visitors probably by the tons?
None of those qualify as thousands of millions. I think on planets there's like 5. And
5 what?
Rogue planets.
Just 5? They're supposed to be everywhere. They've been tossed out by their stellar
From
system.
the statistics of it, it looks like they're fairly common, but yeah.
And the same thing with black holes, little black holes, not supermassive.
That's still an open question.
That's an open question, yeah.
But maybe we have tons of these visitors from other star systems.
Yes.
We just missed them.
Yeah.
Well, we didn't have the technology to spot them before.
Yeah.
I'll bet you that takes off, and we see them all the time. We'll have one every week.
One every week.
Well, when it gets up to 99999I.
Right.
I have to open a Motel 6 for these damn visitors to our solar system. Great, fascinating stuff as usual.
Okay, well, the next topic we're going to cover next week, and was left over from last week, is M17.
Tim's favorite.
Yeah.
I love it.
And the moon will be dark by then, so we're back in faint territory.
17th item Mr. Messier found.
It's really neat. It's
good
really
for bird watchers.
Yeah.
That's what I did in my summer slideshow at Kachuma. I always say, you come out here to go birding, so we're going to show you the wild ducks and the swan.
Yep.
Yeah. Well,
a lot of birds up there. Okay, well, we're going to miss you on October 3rd, Mr. President, but for now, we got things happening this Friday night. Ish Call, who was a graduate student out at UCSB, will speak to us at Farrand Hall up at the museum. Everything's moved up a half hour, at least the planetarium show is. So get there early, and he talks about atmospheres and rain and the galaxy. And I guess we'll see you again next week for number 237, I believe.
Okay.
And how do we say goodbye in astronomy talk, gentlemen?
Hasta Nebula.